So hey guys, so this is another day of solving programming problems. So today we're going to take a look at one of the interesting problems and fun, I would say so fun problems in Geek for Geek, which is to find the problem is called chocolate distribution problem. So the idea is that we are given an array, and the problem is to find a way of distributing this uh, chocolate packets. So, for example, like the first packet would have three chocolates in them, and then the second packet would have four, third one would have one. So the problem is to find a distribution way by which uh, the kid who gets the least amount of chocolate and the kids who gets the maximum amount of chocolate is very minimum. So in this problem, we're given n, which is the number of chocolate packets that we have in our hand right now, and m is the number of students that we have. So the idea is to figure out, is to find an array where we distribute these chocolates to five students, and the difference between the student who gets the lowest number of chocolates and the difference between the student who gets the highest number of chocolate is as minimum as possible. So that's the problem. Um, so I'm going to show you the algorithm that we can use to solve this problem. So initially we get an array, right? So we get an array. In this case, in the code, we're getting an array list, so it's pretty much the same. So what we do once we get the array is that we would sort the array in ascending order. So once we get the array, we would sort them in ascending order, and once we do a sort, the idea is to have and make use of one variable called min. So this will hold the response that we're supposed to return from our algorithms, all right? So what we would do is that we would start from here. So our idea is that we would start from here. We would do an iteration from zero, and then we would take the first m elements in the array. So in this case, it would be I plus m minus 1. So 0 plus 5 minus 1 is 4. So in indexes perspective, we would uh, take all these arrays. So we are going to take all these arrays, all these subarray, and then we are going to subtract the last one, which is here 9 minus 1. We would do that initial subtraction, and then we would find out that the difference is 8. So what is this 8 exactly? So this is the minimum difference that we get if we happen to divide the chocolate packets in a way that we take the first uh, 5 chocolate packets. So we are getting 8 difference between the student who gets just one chocolate in his chocolate packet and 9 chocolates in his chocolate packet. So this is a bit too high, right? So, and then what we would do during the next iteration is that we would increment the value of I, and I would come to here, right? So let me erase all this. We also erase this because we don't need that anymore. So I would come to here, and then we would take the next I plus m minus 1 element. So I is 1 here. So I plus m is 6. 6 minus 1 is 5. So we would take the next sub elements, and then we would subtract the minimum and the maximum here. So like the same thing that we did for this long, we would iterate and get subarrays, get five length subarrays throughout the array. So next we would take uh, the one from here to 12 and the one from 7 to 6. So when we arrive at a situation where we would need to check the condition whether n is greater than I plus m minus 1. So we are checking if we are at the last position here, right? Our iteration, so I plus m, our ending position is indeed less than n. If it goes beyond n, we get a null pointer because there's no more elements beyond that. So we would get all the difference value from all these subarrays, and we would find the most minimum value of them all. So we would find the most minimum value of all these different subarrays, and that is the value that we're going to return from the program. So I'm going to code this now in Java. So before we do anything else, we want to check the base cases. So initially I'm going to do a validation to check if n is equal to 0. So if n is equal to 0 or if m is equal to 0, meaning that we have no elements in the array, or if we do not have any students that we have to distribute chocolates to, what we can do is that we could just return, we return, I guess we could just return 0 because like that's we don't have anything to return, right? So that's the idea there. And is there any other base conditions that we need to check? Oh yeah, so if we are in a situation where m is actually greater than n, meaning that the number of students is actually greater than the total number of chocolate packets we have, then we can't distribute these chocolate packets because we don't have enough chocolate packets, right? So in this case, we have an invalid input, so we are just going to return -1 because the program requires us to return -1. And now we are going to have the min variable that we talked about before. So it will initially set this to recall max value. So integer dot max value. Yep. And then we are going to do the iteration. So as I told you before, so n should be greater than I plus m, which is the number of students that we have, minus 1, and then I plus plus, right? So this is our iteration, and so we need to find the difference between the least element and the highest element in this array, right? So how are we going to do that? So we have an array list here, so we are going to do a get, and we are going to get I plus m minus 1 and subtract it with the first element in the subarray. So arr dot get of I. So this is the difference that we were talking about previously. So initially we took the values from 1 to all the way to 9, right? So we are essentially taking 9 and then subtracting it with 1. So that's what's happening. And yeah, so what we need to do here, so once we get that value, we need to do a comparison. So we need to check if um, minimum is greater than difference, meaning the total minimum that we found out so far is greater than the minimum that we just found with the subarray. And if it is like that, we need to replace the minimum with difference. So that's the idea here. And yeah, so I think that should be it. Um, I don't know if we could return an integer because we are we are in need of a long. So let me see. Let me compile and see if it indeed. Oh wait. Oh, it's a. Not bad. So this is another error there. Ooh, I think we have an invalid. We are facing some issues. What is happening? So guys, I just found out what we were missing. So as I told you, the algorithm is supposed to sort the array. So I missed that out. So I was just going through the code, and it took me some time to figure that out. So we have sorted it. And one thing we could also do is that set this to long here. And yep, that should be it. Yep, submit this. Yep. So we were able to solve this, guys. So that is it for today. See you guys tomorrow with another problem.